Okay, so hello. For our first lesson, we will be going over organic molecules. We will be going over organic chemistry. Organic chemistry, in essence, is the study of organic molecules, which is basically just the carbon element, and carbon element mixed with a bunch of different elements for an oversimplification. And so the first thing we will be going over is the main functional groups that you will see in organic chemistry for this unit. And so I will be going over the basics. So I basically ranked this from highest priority to lowest priority, which will make sense soon enough. And so carboxylic acid is the functional group with the highest priority. You will be seeing a carbon main chain, and I'll be using R for carbon chains per convention. Single bonded to a OH, double bonded to an O. And the suffix for this is oic acid, and you will rarely use carboxy for the prefix. And then we have esters. Esters are basically carbon, main chain, and then it's double bonded to an O, single bonded to another O, which is single bonded to a second carbon chain. And the suffix is O8, and you will rarely use this prefix. And then after that, we have amides, which has a carbon main chain, single bonded to a carbon, double bonded to an oxygen, which is then single bonded to a nitrogen, and single bonded to a second carbon chain, which is single bonded to another carbon chain. Prefix is amide, suffix is amide, prefix is amido. And then nextly, we'll be going over aldehydes. Aldehydes have a carbon main chain, and then carbon double bonded to an oxygen, which is then single bonded to a hydrogen, and that is an aldehyde. You can see that the aldehyde and carboxylic acids are pretty similar, except instead of OH, it's just an H. Suffix will be Al, prefix will be formal. And then we have ketones. Ketones, they basically are a carbon, which is it's like one. Think of this as one big carbon chain, and then it's double bonded to one of the carbons is double bonded to an oxygen. The suffix is "one" but pronounced "own". Prefix is oxo. And then we have alcohols. Alcohols, you can see them at the carbon chain here. You can see that it's single bonded to an OH, and the carbon chain continues in both ways. And so the suffix for this is O, prefix is hydroxy. And then we have amines. There's three types of amines, but I will be just talking about the primary amine for this video. And so amines, it's a carbon main chain, single bonded to a nitrogen, single bonded to a hydrogen, and another hydrogen up here. Suffix is amine, prefix is amino. Alkenes are just carbons, just when there's double bonds in the carbon chains. Alkynes are triple bonds, and alkanes are single bonds. And so suffix is -ine, -ine, and then -ane. And you will rarely use these prefixes, although alkyl you might use sometimes. And so one way I memorize this is A comes before E, which comes before Y. 1 comes before 2, which comes before 3. And so then we have ethers. Ethers are a carbon main chain, single bonded to an O, single bonded to another carbon chain. And there is no suffix, and the prefix is oxy, oxy. You could think of just oxy, so something oxy. And then we have alcoholides. Alcoholides, as the name might suggest, uses halogens. There you will find halogens and alcoholides. So it will basically look like the carbon main chain, single bonded to a Halogen, this could be fluorine, iodine, bromine, chlorine, no suffix, and the prefix is halo. And so that was very brief. That was a very brief introduction to functional groups. Another thing you have to consider is polarity. It's very important for functional groups. So functional groups such as carboxylic acids, alcohols, and alcohols will have very high polarity due to their OH bonds, which is a hydrogen bond, which is the strongest van der Waals force. And then the weaker, lowest polarity will most likely be alkanes, alkenes, alkynes due to their CH bonds, which is a non-polar bond. And so that was a basic introduction to functional groups. And so now we will be going over naming functional groups, naming organic molecules. And so this will be the first questions that we have. We have two molecules here. I'll be going over this first and then this. Over here, we first have to start by identifying the functional groups. We have a carboxylic acid here, and then we have a halogen here. A carboxylic acid has a higher priority than alkyl halides, so we will be starting off here. And so the first step in naming an organic molecule is to count the amount of carbons on the main chain, and we always start counting from the functional group with the highest priority. And since it's the carboxylic acid here, we'll be starting off with 1, 2, 3, 4, 5. And so that's 5 carbons in the main chain. So we will have pent in the middle of the name. And since these are all single bonds, we will be followed by AN to represent alkane. And then the prefix for this will be based off of the chlorine here. And since it's on the 4th carbon, we will put the number 4, followed by a dash, since dashes separate numbers and letters. And then it will be chloro, pentan, and then for the suffix, we have oic, pentanoic acid. And so we have the main, the prefix, and the suffix. And so that is the name for this molecule. And next we will be going over the one next to it. So this is a ether bond. You could see it's single bonded to oxygen, which is single bonded to another oxygen. And so for ether bonds, we will start with, since we could see that there's only 2 carbons here, we will start off with F-oxy. And then a dash. And then we could see that there is, we'll start off counting from here. So 1, 2, 3, 4, and then we have a methyl functional group. So we will have F-oxy dash 1 dash methyl, my bad. It will be methyl butane. So this will be the name for this organic compound. And so that is a quick example of naming organic compounds based off of the given drawings. So basically we have the suffix, the prefix, the mid, and then the suffix. So an ether is kind of an interesting case, but most molecules you'll name similar to the way we named this one, where we have the lower functional groups as the prefix, and then we have the carbon main chain as the middle, and then we have the higher functional group as the suffix. If, let's say, there was another methyl here, we would name it, we would use the alphabet, and so we would say 4-chloro 3-methyl pentanoic acid. So that's how you would name that. And then, for example, let's say we had another chlorine right here. Then we would name it 3,4-dichloro-pentanoic acid. And if we had another chlorine here, that would be 2,3,4-trichloro-pentanoic acid. And so, yep, that's an introduction to naming compounds using drawings. And then we have, this time we will be drawing compounds based off of the names that were given. And so here we have draw the following compounds using IUPAC method: 6-ethyl 5-methyl nonane-3-one, and then pentene-3-ol. Over here, it would be better if there would be a 1 to separate the pent and the ene, but since there isn't, we assume that it's on the first carbon. And so let's actually, no, this does not make sense. It should be pent dash, let's use 2 instead of 3 for this example. And so let's go over this one first. This may look scary, but it's not much at all. So I'll be using skeletal method, which is basically like this. Every point here we assume is a carbon which is bonded to the appropriate amount of hydrogens possible. And so let's get started. So we will draw 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. It's a 9-carbon chain. And then we have a ketone here. So double bonded to an oxygen. So 1, 2, 3, 4, 5. It's a methyl here, CH3. You don't have to put the CH3 where I'm putting the CH3. You could just leave it as here and it's assumed that this is a carbon. And then we have a ethyl group here. So this would be CH2, and then this is CH3. And so yeah, this is literally it for drawing organic compounds using IUPAC method. And then next we will be going over pentene dash 2-O. And so for pentene dash 2-O, we will be having 5 carbons and then a double bond here. And then there will also be a OH bond here as well, since this is an alcohol. And this is it. And then we could assume that there will be 2 hydrogens bonded to the carbon here, a single hydrogen bonded to the carbon here, 2 hydrogens, 2 hydrogens, 3 hydrogens. And so that is a very brief introduction and a couple of examples for drawing organic compounds using IUPAC method. And then next we have, next we have a bit of a more fun example. We have organic reactions. So we will be going over 2 organic reactions. This is a addition reaction. And so we should start off by drawing it out. So we have a 4-carbon chain, right? And then there's a double bonded hydrogen here. So double bonded carbons. So hydrogen, hydrogen, 1 hydrogen, 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 plus hydrogen chloride, which is HCl. And so basically for this reaction, one of these double bonds is going to disappear, forming two bonding capabilities for two of these carbons each. And so following Markovnikov's rule, which states that the carbon with the more amount of hydrogens will gain the additional hydrogen, the hydrogen here will go to this carbon, and then the chlorine will go to this carbon. And so our final product will look like this. Carbon, 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 hydrogen, 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 chlorine, hydrogen, 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 and hydrogen. And so that is an example of a addition reaction. And then our next one is pentanoic acid plus methanol. And so let's draw it first. And so we have a pentanoic acid, one to an OH, double bonded to an O. And then let's just assume that these are all hydrogens. Plus methanol, which will look something like this. Actually, let me redraw it so that it's easier to explain it. So plus, let's say HO, CH, H. And so in this reaction, this is called an esterification because we're basically forming an ester. So we could imagine this popping out to produce H2O, and the O here bonding with the carbon here. And so we will be left with C, double bonded O, and then single bonded to an O, single bonded to a C, bonded to an H, and plus H2O. And then we could assume that these are all just hydrogens. So if we were to name this, we would call it So we would basically just call this methylpentanoate, basically. This will be a methylpentanoate because there's one carbon here and then 5 carbons on the main chain plus water. And so that was a very brief introduction and example for organic chemistry. And so for our next video, we will be going over the structures for chemistry. And thank you for watching. See you in the next video.